this lesson is about systems of inequalities, all right? So we've been dealing a lot with systems of equations. Now we're going to look at inequalities. To understand how to do systems of inequalities, what we have to really focus on is, do we know how to graph a single inequality? All right, and remember, that's when you graph the line is either solid or dashed, and then you shade one half plane versus the other. So what a system means is now we've got more than one inequality. So how are we going to shade it, graph and shade it, and that in turn is how we solve it. So here's the steps to solving. First, we got to get everything in slope-intercept form. All right, then we're going to graph the inequality, each one of them separately on the same graph, and I'll kind of go through that with you in these examples. We're going to determine all the points that can be a solution. A solution is going to be where the two inequality graphs actually overlap each other. All right? We're going to figure that out, and then we end up shading that solution region. And that signifies all possible points that satisfy all inequalities, not just one or the other, but all. So let's take a look here. I'm going to graph the first graph. Y is less than or equal to 1/3 x minus 2. I'm going to put a point at -2 on the y-axis. Go up 1, 1, 2, 3 to the right. Remember, that's the same as down 1, 1, 2, 3 to the left. And then because it's a less than or equal to, I'm going to make this a solid line. Now, for this solid line and the inequality of a less than or equal to, I know that I would be shading below that line. Okay? So I kind of circled that low arrow there. Now I'm going to go to green. And I have y is less than -4/3 x plus 3. That tells me a y-intercept here at 3. The slope says to go down 1, 2, 3, 4, and 1, 2, 3 to the right. And now this line is going to be a dashed line. It's a dashed line because the inequality does not say equals. All right? And I know for this one, I also have it, y's are little. All right, so now what happens is this. If you look at the picture, there are 1, 2, 3, 4 different regions that now get created. All right? I have to think my way through these regions. Now, the first graph said it had to be less than this blue line. So I know I'm either dealing with region 3 or region 4. It's either going to be one of those two regions that'll be shaded because that's less than the blue line. The second one says less than the green line. So then I know it's got to be this region right here. And then I end up shading that. And remember, again, what the shading is representing is any point that I pick inside of this region will satisfy both the first and the second inequality. Okay, so let's try another one here. Y is greater than -x plus 1. Graph 1, slope says go down 1, 1 to the right, down 1, 1 to the right, and I'm just going to continue to make those marks just because it makes it easier for me to graph. I can also move up 1, 1 to the left, and that creates this line. I'm going to go ahead and draw a dashed line here. And I know that they're talking about y's that are big. Okay, let's graph the next line. Y is greater than or equal to x plus 3. I'm going to use a green line. Put a dot there at 3. Slope says go up 1, 1 to the right. Up 1, 1 to the right. Same as down 1, 1 to the left. Down 1, 1 to the left. Down 1, 1 to the left. And that pattern continues. And this line will be solid because it was a greater than or equal to. Right? That one says that y's are big as well. So again, I've got, and you can number them any way you want. I've got 1, 2, 3, 4 regions. All right? I know that the first inequality is the dashed line. It says y's are big in region 2 and region 3 for the blue line. The green line says y's are big for the green line? Well, that's going to be region 1 and region 2. Where do they overlap? You should see how region 2 has a couple of circles around it. So that's going to be the region then that I shade. And every point in that region is a solution to both inequalities. All right, let's take a look at example number 3 here. All right, first inequality. I'm going to shade or graph the 1. Slope says go down 1, 2, and 1, 2, 3 to the right. All right, I could also go up 2 and 1, 2, 3 to the left. And it's a greater than or equal to, so this line will be solid. Okay, the second one is a special line. All right, I know it's a special line because there are no y's. It says x is less than -3. So on the x, I'm going to graph -3, and I know this represents a vertical line. And I used the wrong flavor there, so let me fix this up. I meant to use green. So at -3, and then we have a dashed line vertically right there. This creates 1, 2, 3, 4 different regions. For the blue line, the inequality says y's are big. That's up in region 2 and 3. For the green graph, that's x is less than -3. That is region 1 and region 2. The overlap occurs up here in region 2. All right? So what happens if they don't give us an inequality written in slope-intercept form? All right, like example 4 here. Well, I have to get it in the slope-intercept form. So the first inequality is going to be y is less than -1x plus 2. I'm going to go ahead and graph that. Y-intercept's at 2. Slope is down 1 over 1 to the right. Same as up 1, 1 to the left. And I know that this graph is going to be solid. Now I'm going to go to the second inequality. It says 6x plus y is less than or equal to -3. That's going to be y is less than or equal to -6x minus 3. Graph the y-intercept at -3. Now the slope says go down 6 and 1 to the right. Well, I can't go down and right because I'd be off the screen. So I need to go up 6 and 1 to the left. So I go up 1, 2, 3, 4, 5, 6, 1 to the left. And I know that this line is also going to be a solid line. All right, so my graphs have now demonstrated that there happen to be 1, 2, 3, 4 regions that get created. The blue graph says y's are little. That's down in 1 and 4. The green graph says y's are little as well. Now this little is a little bit tricky. That's actually going to be region 2 and region 1. The overlap occurs over here in region 1. So this is what I shade. Right? And again, the shading represents every possible solution that would satisfy both inequalities. So let's try a couple more like that. Got another special case here. So let's go ahead and graph the first one. It says y is greater than or equal to 3. I know that this is a special line. This line is going to be a horizontal line. And there's its graph. All right. The second line, I got to solve this for x. So I'm going to have -1y is greater than or equal to -2x plus 3. But that's not solved for y. I got to divide everything by -1. Remember, when you divide by a negative, that flips the inequality sign. And my actual graph is this: y is less than or equal to 2x minus 3. Graph -3, slope says up 2, 1 to the right. Or down 2, 1 to the left. I know this is a solid line. And again, identify the regions that get created. I got 1, 2, 3, 4. All right, from the blue graph, that's the y is greater than 3. From the blue graph, I know it's either going to be region 2 or region 3. The green graph says y's are little. Y's are little in region 3 and region 4. So my solution is the overlap here in region 3. All right, so let's take a look at this last one. I'm going to solve the first inequality for y, get it in a slope-intercept form. That would leave me with negative 1y is less than or equal to negative 3x plus 1. Divide by a negatives tells me to flip the inequality, and then it becomes y is greater than or equal to 3x minus 1. Let's go ahead and graph that now that we've got it. Y-intercept at negative 1. Slope says up 1, 2, 3, and over 1. Up 1, 2, 3, and over 1. Or down 1, 2, 3, and over 1. This is going to be a solid line, creating two half planes. I come over to another graph. The second one, 3x minus y is less than or equal to negative 3. I solve for y, so I have negative 1y is less than or equal to negative 3x minus 3. I divide by negative 1. That gives me y is greater than. I flip the inequality because I divided by a negative, and I get 3x plus 3. This is the inequality that I have to graph. It has a y-intercept at 3. Slope says go up 3 and 1 to the right. Well, if I went up 3 and 1 to the right, I'm off the chart. So I'm going to go down 1, 2, 3, and 1 to the left. Down 1, 2, 3, and 1 to the left. And this is a solid line as well. Now, if you notice, something unique is happening with this picture. I know my lines aren't drawn perfectly, but I notice that both of these have the exact same slope. That tells me that these lines are parallel. All right, these parallel lines still create regions, 1, 2, and 3. All right, I go to the first one, the blue graph, and it says y's are big. Well, y's are big for the first graph in region 1 and 2. I go to the second graph. Second graph says y's are big. Y's are big for the green graph over here just in region 1. So my solution is just going to be here, region 1. And I shade that, and any point that is in this region will satisfy both the first and the second inequality. Hope this helps. Make sure you guys do worksheet 2-3A. All right, and let me know if you got questions.